Yeah, I get.
I got it. So let's say there's 5 feet, and then there's 10 feet. Then there's 40 inches here. And then this way, there's 126 inches. So that means that there would be, hold on, from here. Now from here, there's this individual covers about 60 inches horizontally while covering 50 inches vertically here. So we have two different equations. Here we have an athlete, myself, covering 10.5 feet of jump distance for 126 inches, 40 inches in jump height. And then here we have 60 inches horizontally and 50 inches in jump height. Now, more accurately for me would be around 44 to 45 here, because I do reach my peak in front of the Vertec. So I'm usually hitting my peak somewhere around here, and I'm not hitting my peak directly on the Vertec. So I'm coming down by the time I get to the Vertec somewhere around here. Like, this is where I'm hitting the Vertec, because it's so hard for me covering this much distance to hit this small distance. Is very accurate for me to gauge. Now, someone that only covers 5 feet of distance of 60 inches with a 50-inch vertical leap, it's going to be a lot easier for them to gauge where that Vertec is and be more accurate, and to get that vertical leap to go all vertical, straight up and down. Whereas here, a lot of the vertical leap is being distributed horizontally. So I'm going to be taking a look here at the distance underneath the curve by using Riemann sums. So Riemann sum would be something like so let's do it into 5 blocks. So I'll have this block. No, this is just gonna be an estimate. And then I have, it's tough. Why don't I just do a triangle? It'll be easier for the sake of this, it'll be easier to just do it as a triangle. So you do, to find the hypotenuse, we're gonna do base times height. So base and height, you're going to use Pythagorean's theorem to determine the length of that hypotenuse. So we have 60 inches cut into 2 would be 30 inches plus 50 inches squared. That's going to equal our hypotenuse, which we're calling c squared. So 900 plus 2500 equals 3400. 3400 equals c squared, which would put our hypotenuse at the length of our hypotenuse. Now this could be like our true vertical in a way. This would be like your true vertical leap. So what's the square root of 3400 would be the square root of 3400. The square root of 3400 is 58.3. So C is 58.3 here for this athlete. So the hypotenuse was 58.3. Now for myself, let's say, so half of 126 would be 63 squared plus 40 squared equals 1600 plus, what's 63 times 63? Big numbers here. Ain't no 30s, we're talking about 60s.
What was it?
63 times 63. So 63 times 63 is 3969 plus 1600 equals 5569. Now the square root of 5569. Square root of 5569 is 74.62. So I actually have a greater hypotenuse. I have a greater hypotenuse, but I don't have a greater vertical leap. I have a greater hypotenuse, but I don't have a greater vertical leap. But I'm covering a lot more overall distance that's being covered. So for this equation, the athlete with the 50-inch vertical leap covering 5 feet of distance, they have the hypotenuse of 58.3 inches. Now myself, who covers 10.5 feet of distance, we're calling this 40 inches, even though it's usually 44 to 45, puts me at 74.6 on my hypotenuse. So there's a much greater hypotenuse here than the athlete who travels straight up and down on this parabola, where this rainbow of a parabola, the hypotenuse was a lot greater. So it just makes you think, this athlete, if they had the same amount of hang time, two athletes that had the same amount of hang time, and one athlete was covering more distance than the other, you could see how the apex of that parabola, of that vertical leap, can really be altered based on the amount of distance of that jumper and whether or not that leaper is accurately getting the peak of their vertical to that vertex. Because for myself, I'm about a foot in front of it, and I'm getting 3 to 4 inches over what I'm actually reaching. And each month, consistently for the past 4 months, I've been testing around 40 to 41 inches on the Vertec off 1 feet, and around 39 inches off 2 feet, and been consistently over these 4 months. And the same thing I'm noticing every time is that parabola, and I'm really the same thing I'm noticing every time is that parabola, and I'm really losing 3 to 5 inches on that jump due to the amount of distance that I'm covering. So it just really makes me think, if if the distance is shortened, of the parabola for an athlete, the amount of distance and space they're covering while they're jumping, that jumping height could be potentially higher, but overall they're covering a greater distance at a greater height and are much greater of a threat in the scheme of basketball to block a shot or grab a rebound or make a play, because you're in the air at a higher height for a much further distance of time. That's cool, you're jumping 50 inches, but you're going straight up and down. I'm over 11 feet, over 12 feet in the air for multiple feet. I'm traveling several feet above 11, 12 feet in the air. So you see the difference there, 74.62, 58.3. Distance leapers, it's actually covering some ground. Stay tuned for the next video.